Next up is number density and drift velocity. In a metal, the atoms have some electrons that are fixed to the atom and some that are called free electrons that can move around. The metal atoms sort of share their free electrons between them, and it's because of the free electrons that metals can conduct a current easily. Other materials don't have as many free electrons or other free charged particles, so they can't conduct current as easily. The number of charge carriers per metre cubed that are free to move is called the material's number density. And so here you can see that the materials that we call conductors, like copper, have very large values of N, and the materials that we call insulators, like air, have very low values of N. And then somewhere in the middle we have the materials we call semiconductors, like silicon, and they have sort of medium values of N. Thinking about a copper wire now, imagine we could see the free electrons in the wire. How are they moving when the wire is not connected into a circuit, so no power supply? In fact, the electrons move very quickly and in all directions, but all this movement of charge sort of cancels out, so overall there's no movement of charge and no current. If we now connect the wire to a power source, we find that the electrons are still moving quickly and in all directions, but they are also all being pushed slowly along the wire by the power source, so overall they are also drifting slowly along the wire. And this means that now there is an overall flow of charge, and that's how come there's a current. Remember that electrons move away from the negative and towards the positive, whereas current, by convention, flows from positive to negative. This is the formula for drift velocity. Remember that in a wire, the charge carriers are electrons, so little e there is going to be 1.6 times 10 to the minus 19 because we don't care about the minus sign at the front. Pause the video now to have a go at a drift velocity question. Okay, so first up, the cross-sectional area is this area here. So we have this for the first mark, then there's your formula and rearranging for the second mark, then put all your numbers in correctly for the third mark, that'll give you this, and then for the last mark multiplying by 60 to get the distance per minute.